Hello, dear student. How are you doing? I hope you have done well in your mock test. As you know that we are studying chapter number 2, acid, bases and salt. In the last video, we had started with the topic more about salt, and in that, we had discussed some salt preparation properties and uses. So, we will continue today with the same and will try to complete the chapter. So, let us begin with the next salt, that is washing soda. Many of you, dear children, are familiar with this salt, washing soda, used in our homes for many domestic purposes, especially for cleaning. So let us see first its property, then we will see its preparation and uses. Washing soda is a white colored, odorless, that is without smell powder. Its chemical formula is Na2CO3 and it is known as chemically sodium carbonate. It is hygroscopic in nature, which means that it absorbs moisture from the air. It is highly soluble in water and forms strong alkaline water solution. So we can say that washing soda is a basic salt. Now let us see the preparation of washing soda. Sodium carbonate, that is washing soda, is manufactured by Solvay process. It is known as ammonia soda process. As we have discussed, sodium chloride when react with water, carbon dioxide and ammonia, it forms sodium hydrogen carbonate, commonly known as baking soda. This baking soda on heating decomposes to give sodium carbonate, that is washing soda, along with water and carbon dioxide. Recrystallization of sodium carbonate also gives washing soda. You can see here the chemical reaction written for the preparation of sodium carbonate. Now let us see the uses of sodium carbonate. Sodium carbonate is one of the most important salt used in manufacturing of glass, soap, paper, rayon and detergent. It is also used to remove the permanent hardness of water. It is used to control pH. In many chemical industry, it is used to synthesize many different sodium compound, including sodium bicarbonate, sodium silicate, sodium tripolyphosphate, sodium hydroxide, sodium chromate, sodium dichromate, sodium aluminate, sodium cyanide, etc. Sodium carbonate is also used as a cleaning agent for domestic purposes. Now let us begin with the next topic, water of crystallization. Are the crystals of salt really dry? Let us understand this with the help of an activity 2.15 given in your book. As you can see in this figure, a test tube is being taken. And in this test tube, few crystals of copper sulfate salt is added. The color of this copper sulfate salt is blue. Now, we will heat the test tube containing copper sulfate crystals and we will observe what happens after heating. After heating, we can see some droplets of water in the test tube. This is because copper sulfate crystal seems to contain some water molecules. When we heat the crystals, they become dry and the water present in them removed and the salt changes its color from blue to white. If we moisten the dry crystals again with water, the blue color of the copper sulfate crystals reappears. This experiment suggests that there are certain salt which contain fixed number of water molecules in them. Now we can define water of crystallization. Water of crystallization is the fixed number of water molecules present in one formula unit of a salt. It refers to water, number of water molecules chemically bonded inside solid crystal form. Water molecules are the part of the crystal structure. This water is responsible for the geometrical shape and color of the crystal. As for example, in case of copper sulfate, there are 5 molecules of water which are associated with it. Due to this, it is blue colored crystalline solid soluble in water. Because of the blue color of copper sulfate, it is commonly known as blue vitriol. Now let us see another hydrated salt. This we have already discussed in this chapter. Washing soda. Its formula is Na2CO3 dot 10H2O. Chemically, washing soda is called sodium carbonate decahydrate. Let us now see a list of some more hydrated salt. Here is a list of some hydrated salt with their common name. CuSO4 5 molecules of water, that is copper sulfate, hydrated, is commonly known as blue vitriol. Gypsum, that we are going to study next, another hydrated salt, formula is CaSO4 2H2O. Chemically it is called calcium sulfate dihydrate. See another example of ferrous sulfate hydrated, which is commonly known as green vitriol. Let us discuss two hydrated salt. Gypsum. This salt has two water molecule as water of crystallization. Its formula is CaSO4 dot 2H2O. Gypsum is chemically known as calcium sulfate dihydrate. Let us see the preparation of gypsum. Gypsum can be obtained from plaster of Paris on adding water to it. You can see here the equation in which calcium sulfate hemihydrate on mixing with the water gives calcium sulfate dihydrate, that is gypsum. Calcium sulfate hemihydrate is another hydrated salt that we are going to discuss next. Let us now see some common uses of gypsum. Gypsum is used in making ceiling tiles, paints, joint compound. It is used as a plaster, as a cement, as a filler and pigment use, in glass making, and in making other chemicals. Now, let us discuss another hydrated salt, that is plaster of Paris. Plaster of Paris is a fine white powder which hardens when moistened and allowed to dry. Known since ancient times, plaster of Paris is so called because of its preparation from the abundant gypsum found near Paris. Plaster of Paris, as you now know, chemically known as calcium sulfate hemihydrate, and its formula is CaSO4 dot half H2O. Here you have to understand that water molecule cannot exist as half molecule. All the compound exist in their stoichiometric ratio, that is in whole numbers. So practically, two formula unit of calcium sulfate share one molecule of water. Let us see the preparation of plaster of Paris. Plaster of Paris is obtained on heating gypsum. Calcium sulfate dihydrate, that is gypsum, on heating at 373 Kelvin becomes calcium sulfate hemihydrate, that is plaster of Paris. Plaster of Paris thus obtained on mixing with water, it changes to gypsum once again, giving a hard solid mass. Let us now see some uses of plaster of Paris. Plaster of Paris is used to make statues and metal casting used as decorative in buildings. It is also used in buildings to avoid fire hazard, as plaster of Paris is fire resistant. It is used as a coating on wood and metal structures to avoid any fire accidents. Plaster of Paris is used by the doctors for supporting fractured bones in the right position. It is the substance which is used for making toys, materials for decoration, and for making surfaces smooth. Students, now I will be discussing with you some chemical compounds with their common name and chemical formula. Here is the list of some compounds with their chemical and common name along with their chemical formula. Sodium chloride, commonly known as table salt, and its formula is NaCl. Sodium hydroxide, commonly known as caustic soda, and its formula is NaOH. Third, calcium oxychloride, commonly known as bleaching powder, and its formula is CaOCl2. Fourth is calcium hydroxide, commonly known as slaked lime, and its formula is CaOH whole twice. Fifth is calcium oxide. It is commonly known as quicklime and its formula is CaO. Sixth is sodium hydrogen carbonate, commonly known as baking soda, and its formula is NaHCO3. Seventh compound is sodium carbonate, commonly known as washing soda, and its formula is Na2CO3 dot 10H2O. It is also called hydrated sodium carbonate or sodium carbonate decahydrate. Let us see the next compound 8, hydrated copper sulfate, which is commonly known as blue vitriol. Its formula is CuSO4 dot 5H2O. The next compound is calcium sulfate dihydrate. It is commonly known as gypsum and its formula is CaSO4 2H2O. The 10th compound is calcium sulfate hemihydrate. It is commonly known as plaster of Paris. Its formula is CaSO4 half H2O. The 11th compound is methanoic acid. It is commonly known as formic acid. Its formula is HCOOH. We have studied that the formic acid is the acid found in the ant sting. The next compound is magnesium hydroxide. It is commonly known as milk of magnesia and its formula is MgOH whole twice. Students, like this, you can also find out various compound, their common names and formula, and you can make a list of that in your fair copy. Now let us see the table given in your book, table 2.3, in which the name of some acids are given and their sources from which they are obtained. The first acid, as you can see in this figure, is acetic acid. It is obtained from vinegar. The second acid is citric acid and its sources is orange. The third acid is tartaric acid obtained from tamarind. The fourth acid you can see here is oxalic acid obtained from tomato. Lactic acid is found in sour milk, or it is also present in the curd. Citric acid, another source is lemon. You can see here methanoic acid, which is found in ant sting as well as in the plant nettle sting. By this, we come to the end of the chapter Acid, Bases, and Salt. I hope you have understood each and every topic of the chapter. There are some easy topic and some you will find difficult to understand. I will ask you to read the chapter again and again to understand it better. Learn the chemical equations of the chapter. Learn the names, chemical as well as common names and formula. Write them to learn it better. Go through the notes that I had provided you and write the book question answers in your fair copy. Students, if you are finding any portion that is difficult or you are not able to understand, then you can contact me. I will try to help you out. In the next video, we will be starting with the third chapter, that is metals and non-metals. Till then, take care of yourself. Thank you.